Hi, Mr. Wright here, and welcome to this film on functions. In this film, I'll take you through 17 IGCSE questions on functions. Now, all of these questions are pretty feisty, so you will need to be au fait with the concepts of the domain and the range of a function. You'll need to be able to use composite functions numerically and algebraically. You'll need to be able to find inverse functions, which requires you to rearrange formula to make generally x the subject of a formula. And sometimes when you're rearranging these formula, you need to deal with quadratic expressions, in which case, to rearrange, you need to be able to complete the square. So there's an awful lot of maths in these questions, an awful lot of algebra. They are feisty, grade 7, 8, 9, a lot of them grade 9 questions. So good luck, take it steady, hit the link in the description, download the questions, and then you can work on the questions and then watch me go through them, or you can work alongside me. If you've got any questions or if anything isn't clear, please leave me a comment, and of course, I'll respond. If you find the film useful, please leave me a comment. If you find the subject tough or easy, leave me a comment, let me know. Hit like, make me feel good about myself and the film. Right, let's get on with the maths. Good luck, download the questions, have a go. Let's get on with the maths.
Question 1. Right, we've got a function f defined as shown there, and we're asked to find the value of the function when x is 10. Or you might say we're asked to find f of 10, or you might say we're asked to f10, if you want to think about the function as being a verb. Now, the function is 2 times x over x minus 6, so that's going to be 2 times 10 over 10 minus 6, which is 20 over 4, so is equal to 5. Right, part B, express the inverse function in that form. Right, well, I know that f of x is equal to 2x over x minus 6. Now, I'm always going to do this in the same way. I'm going to write y equals 2x over x minus 6, and now I'm going to make x the subject of this formula here, x the subject. So I'm going to multiply both sides by x minus 6. It's going to give me y, lots of x minus 6 equals 2x. Let's multiply that bracket, xy minus 6y equals 2x. Now I'm trying to make x the subject, so I'm going to put x, anything with an x in it, on the left, and all the other rubbish on the right. So I'm going to minus 2x from both sides, which is going to give me xy minus 2x. And I'm also going to add 6y to both sides, which gives me 6y on the right. Now, how am I going to make x the subject here? Well, the answer is, because x appears in both of those terms here, I'm going to factorise that. It gives me the left-hand side is x lots of y minus 2 equals 6y. And now you can see that you can make x the subject by dividing both sides by y minus 2. So, the inverse function, f to the minus 1 of x, is 6x over x minus 2. I've simply substituted x in there instead of those y's. Now, in this question, it wants me to give it in this form. F to the minus 1 x is transformed to 6x over x minus 2. So I'll write the answer in here. And that is question 1 complete. Question 2. Now in this question, we've got two functions defined, f of x and g of x. State the value of x that cannot be included in any domain of g. What cannot be an input of g? Well, the answer is that if the x that you insert into g makes the denominator equal to 0, then that value of that fraction will be undefined. So, the value of x we're looking for is the value of x which makes that denominator equal 0, which is, of course, x equals minus a third. So that's the value of x which cannot be included in any domain of g. Part B. Find gf of x. What we're going to do here is we're going to start with x. We're going to f it first, and then we're going to g the result. Now, I already know the result of fing x. The result of fing x is 2x minus 3. So what I'm going to do is I'm going to g 2x minus 3. Now, I know how g of x works. G of x is x over 3x plus 1. So if I'm going to g 2x minus 3, then that's going to give me 2x minus 3 over 3 times 2x minus 3 plus 1. What I've done here is I've substituted in 2x minus 3 for x. Okay, so I've just got to simplify that now. 2x minus 3 over 6x minus 9 plus 1. 2x minus 3 over 6x minus 8. Okay, part C coming up. Express the inverse function g to the power of g to minus 1 in the form g minus 1 of x. Right, let's start by writing down g of x. We'll do this in exactly the same way as always. G of x is x over 3x plus 1. So I'm going to write y equals x over 3x plus 1. And now I'm going to make x the subject of that expression. Multiply both sides by 3x plus 1. Multiply out the bracket. Get anything with an x on it on the left and anything else on the right. I'm going to subtract x from both sides. And I'm going to subtract y from both sides as well. Right, factorize the left so you know what to divide by to make x the subject. I'm going to divide both sides by 3y minus 1. Now, I can now write down the inverse function, g to the minus 1 of x, by substituting x in here. So it's going to be minus x over 3x minus 1. So that will be my answer here, minus x over 3x minus 1. Of course, if you prefer, you could write that as x over 1 minus 3x, multiplying top and bottom by minus 1. And that is question number 2 finished. Question 3. Right, I've got a function, f, which is defined there, and I'm asked to find f of a third to evaluate the function when x equals a third. So f of a third will be 2 over 3 times a third minus 5. Well, that's 2 over 1 minus 5, which is 2 over minus 4, which is minus a half. Now I'm asked to find the inverse function. Okay, so I'm going to do this in the same way as ever. I'm going to write y equals 2 over 3x minus 5, and I'm going to make x the subject of this. So I'm going to multiply both sides by 3x minus 5. Multiply out the bracket. Now anything with an x on it, on the left, anything else on the right. So I'm going to add 5y to both sides. 3xy equals 2 plus 5y. And now I'm going to divide both sides by 3y, so that x is the subject. And so now I can write down the inverse function by copying my expression, but instead of these y's, I will write an x. 2 plus 5x over 3x. Okay, part C. The function g is such that, and there it is defined there, express g of x in the form a lots of x minus b squared plus c. Essentially, I'm simply being asked to complete the square on this expression here. Now, Completing the square is something that you need to learn how to do quite fluently. In this case, I'm going to pull 5 out of the first two terms so that I have a unitary x squared, because that's going to make life easier. Now, 5, open a square bracket. I'm going to complete the square on this expression here. Now, it's x squared minus 4x. So I'm going to need x minus 2 squared. That will give me x squared minus 4x plus 4. So I'll need to subtract away that extra plus 4. Copy down the plus 23. Let's multiply out the square bracket. 5 lots of x minus 2 squared minus 20. Copy down the plus 23. 5 lots of x minus 2 squared plus 3. And there is my answer to part C. That is question 3 done. Question 4. Here I'm given two functions, g and h. Okay. What value of x must be excluded from any domain of g? Well, the answer to that is that it will be the value of x which makes that denominator equal to 0. Because if you have a denominator equal to 0, then your value of g for that value of x will be undefined. So what value of x makes the denominator equal 0? Well, the value of x which makes the denominator equal 0 is 2.5. Solve the equation gh of x equals 1. So I need to work out algebraically what's that left-hand side going to look like. Well, I know that h of x is x squared plus 4. So if I'm going to g that h of x, I'm going to need to g x squared plus 4. Now, how do I g something? Well, I'm looking up here now to see how I g something. And the way that I g something is that I write 11 as the numerator. Then I have twice what I'm g'ing, so twice x squared plus 4. And then I take away 5. All right, let's carry on and simplify that, shall we? That's going to be 11 over 2x squared plus 8 minus 5. 2x squared plus 3. So that is gh of x. And the equation I'm being asked to solve is that gh of x, which is 11 over 2x squared plus 3, equals 1. Well, I can solve that equation, multiply both sides by 2x plus 3. 11 equals 2x squared plus 3. Subtract 3 from both sides. So that gives me 8 equals 2x squared. I'm going to turn it around the other way. 2x squared equals 8. X squared equals 4. So x could be plus or minus 2. Now let's just come up to the top and check there's no restrictions on the value of x. Look at this. X has got to be greater than or equal to 0. So one of these solutions is invalid. And my answer to the equation must be that x is 2, because the possible answer x equals minus 2 is not valid according to the definition of the function h. And that is question 4. Question 5, there you are. I'm given the function f, and I'm asked to work out f of 5. I'm asked to take 5 and f it. So f of 5 will be 4 minus 3 times 5, 4 minus 15 minus 11. Now I'm told the function g is defined like that. Find the value of x which cannot be included in any domain. Well, it's going to be the value of x which makes that denominator equal 0. So what value of x makes that denominator equal 0? If you're not sure, you could solve that equation, but the answer is that x equals a half cannot be included, because that makes the denominator equal 0. Right, work out fg of minus 1.5. So I'm going to start by g'ing minus 1.5. So let's do that first. G of minus 1.5 is 1 over 1 minus 2 times minus 1.5. 1 over 1 plus 3. Oh, that's a quarter. Okay, so now I'm going to have to f the result of g of minus 1.5. So I'm going to f the quarter. Right, now to f something, what do? 4 minus 3 times a quarter. Well, that is 4 minus 3 quarters, which is 3 and a quarter, or 3.25. And that is question 5 complete. Question 6. Right, I've got f defined as k over x, and I'm asked to express the inverse function in that form. So I'm going to start by writing y equals k over x, and I'm going to make x the subject, multiply both sides by x, and then divide both sides by y. So x will be k over y, so the inverse function is going to be this expression here, with x substituted there in place of the y. So it's going to be k over x. K over x, I beg your pardon. Right. The function g is such that g of x is 2 minus 3x to the power of 4, where x does not equal 0. And there's the function h, which is defined like that, where x does not equal 2. Find g of minus 2. So what we're going to do is we're going to take minus 2 and we're going to g it. Well, when you g something, you do 2 minus 3 times the something to the power of 4. That's going to be 2 minus 3 times, right, 2 to the power of 4, 2, 4, 8, 16. And that's plus 16, of course, because it's to an even power. So that's 2 minus 48 minus 46. Okay. Right. Express the composite function hg in the form hg of x, giving your answer in its simplest form. So we need to find an algebraic expression for hg of x. Well, that is hing g of x, isn't it? And I know what g of x is. G of x is 2 minus 3x to the power 4. So actually what I've got to do is I've got to h 2 minus 3x to the power 4. Now how do I h something? And I need to be looking here. How do I h something? Well, I multiply it by 3. So I better multiply this expression by 3. And then I do 2 minus whatever it is I'm hing. Now put that in a bracket so you don't mess up your signs. There we go. So that is the expression for h of x with 2 minus 3x to the power 4 substituted in instead of x. And all I've got to do now really is just simplify that. So on the top, I'm going to have 6 minus 9x to the 4. And on the bottom here, I've got 2 minus 2 plus 3x to the power 4. Okay, well that is 6 minus 9x to the power 4 over 3x to the power 4. Now, can I simplify that? Be careful, but yes you can. You can divide 3 into the top and 3 into the bottom. Gives you 2 minus 3x to the power 4 over x to the power of 4. And that is hg of x in its simplest form. And that is the end of question 6. Question 7. Right, the functions f and g are given to me there. State which value of x cannot be included in any domain of g. Well, it's the value of x which is going to make the numerator 0, the denominator 0, and that value of x is going to be 4.5. All I've done there is solve the equation 2x minus 9 equals 0 to find the value of x, which makes 2x minus 9 equal 0. Find fg of 4. Right, well I better g4 first, hadn't I? So if I'm going to g4, then that'll be 5 over 2 times 4 minus 9, which is 5 over 8 minus 9, which is 5 over minus 1, which is minus 5. So now I'd better f the result of g'ing 4, so I'm going to f minus 5. So that's going to be 5 times minus 5 plus 7. Minus minus 25 plus 7, which is minus 18. Right, now I'm given the function h. Now I'm told here that x is greater than 2, and I'm going to need to remember that in a few minutes. Right, I have to find the inverse function here. So I'm going to do it in my same old way. Y equals 3x squared minus 12x plus 8. Now, I'm going to need to make x the subject here. Now, because I've got a quadratic there, I know I'm going to need to complete the square. So that's going to be y equals. Now, I'm completing the square here. First thing I'm going to do is to pull out a 3 so that I have a unitary x squared, because I know that's going to make life easier. And now I'm going to write 3, open a square bracket, and complete the square on x squared minus 4x. Well, that's going to be x minus 2 squared, because that's x squared minus 4x, but then I'll have an extra plus 4, so I should minus that away. Plus 8. Right. Let's carry on simplifying that, shall we? Multiply out this big square bracket. 3 lots of x minus 2 squared minus 12 plus 8. So y is 3 lots of x minus 2 squared minus 4. Now I've completed the square there. I can now make x the subject. What I'm going to do is I'm going to add 4 to both sides. So y plus 4 equals 3 lots of x minus 2 squared. Divide both sides by 3. Y plus 4 over 3 equals x minus 2 squared. Now I'm going to square root both sides. Remember, I'm going to get 2 answers to my square root on the left. So I need to bear in mind that I've got 2 answers here. So it's the square root of y plus 4 over 3. Okay, there we go. And that's going to be x minus 2. Now I'm going to add 2 to both sides. So it took me quite a long time to understand this, but it's quite straightforward. Let me show you. When you add 2 to both sides, I would always be very tempted on the left to write plus or minus, and then y plus 4 over 3, and then write plus 2. It took me ages to understand why generally when a maths teacher adds 2 to left and right of that equation, they just write 2 and then they copy down the plus or minus and the square root. And they have added 2. They've just written it before the square root plus 2 plus the rest rather than the rest plus 2. Anyway, it took me ages to understand that. I don't know quite why. Right, so now I've made x the subject. Okay. So I can now write my inverse function down. So I can say that h, the inverse function, h to minus 1, is, and I'm going to copy down this expression here, but instead of a y, I'm going to put in an x. So 2 plus or minus the square root of x plus 4 over 3. Now be careful. Let's go back to this question here, and you'll see it tells you that x must be greater than 2. Well, that means if x must be greater than 2, then this function here cannot be, I'm looking over here, this function here cannot be 2 minus anything, because that would give you less than 2. So it must be 2 plus the square root. And 2 minus the square root is not going to be a valid solution. So the correct answer for the inverse function here is 2 plus the square root of x plus 4 over 3. Okay, and that's a tricky question, that part C there, where you have to find an inverse function and you need to complete the square and then take one of your solutions. But it'll come up time and time again, and you will get used to solving them. But that's question 7 done for now. And I bet question 8 will involve the same thing. Let's find out. Question 8. G is the function with that domain. Remember, that means that whatever goes into G must be greater than or equal to minus 3. And then you're told what g of x is. Write down the range of the inverse function. This is a bit of a trick question, really, because they're saying to you that what goes into G, what goes in, must be minus 3 or more. And then when they ask you for the range of the inverse function, they're saying, what can you tell me about what comes out of the inverse function? Well, the inverse function is going this way, and you know what comes out must be greater than or equal to minus 3. So your answer here really is that the inverse function must be greater than or equal to minus 3. Now it asks you to express the inverse function in this form. Let's have a look. So y equals x squared plus 6x. I'm going to make x the subject of that expression. It's quadratic, so I'm going to have to complete the square. So that's going to be y equals, right, completing the square on x squared plus 6x. X plus 3 all squared gives me x squared plus 6x, but an extra 9, so I'll subtract that 9. And now I can make x the subject here. Add 9 to both sides. Okay. Square root both sides. Remember, 2 answers to a square root. Now subtract 3 from both sides. So I've got x plus 3 equals the 2 square roots of y plus 9, and I'm going to subtract 3, so I'll just have x on the left, and on the right I'll have minus 3, and then plus or minus my square root. I've just written that minus 3 at the beginning of the expression again. So it looks like the inverse function is going to be that x becomes minus 3 plus or minus the square root of x plus 9. I've just substituted an x there instead of the y. Now look out, because I'm told that x must be greater than minus 3. Sorry, over here. I'm told that here, aren't I? I'm told here that x must be greater than minus 3. So x can't be minus 3 subtract something. So actually, my only valid answer here is minus 3 plus the square root of x plus 9. So that is the answer. And this answer here would lose you a mark because you've included an answer which is not valid. And that is question 8 done. Question 9. Okay, I'm given 2 functions here, f of x and g of x. And I'm asked to solve the equation fg of x is greater than 0. Sorry, to solve the inequality. All right. Let's first of all get an expression for fg of x. Now I know that g of x is 2x plus 1. So really what I need to do is I need to f g of x. I need to f 2x plus 1. So that's going to be 2x plus 1 squared minus 4. Okay, let's carry on simplifying that, shall we? 2x plus 1, 2x plus 1 minus 4. 4x squared, now I'm going to have plus 2x and plus 2x, that's plus 4x plus 1 minus 4. Okay, so 4x squared plus 4x minus 3. So that is fg of x, and I'm being asked to solve the inequality fg of x is greater than 0, which of course is the inequality 4x squared plus 4x minus 3 is greater than 0. Right, well, I'm thinking in my head of this equation now. Okay, and if I was solving that equation, I could use the formula, or I could look to factorise. I'm going to look to factorise. Okay, now it's either going to be 2x and 2x or 1x and 4x. I'm going to go 2x and 2x. Now I've got to multiply to minus 3, so I'm thinking about 3 and 1. Well, minus 1 and plus 3, or plus 3 and minus 1. I've got plus 4x there, so I'm going to try the plus 3 and the minus 1 and just check but that does give me 4x squared. It does give me minus 3 at the end, and look at that, plus 6x minus 2x, it gives me plus 4x as well. So my solutions to this equation here, that x would be minus 3 over 2, or a half. Now, what does that mean about the solutions for this quadratic inequality? Well, it's got a positive x squared here, so I'm thinking about a U-shaped curve here, and I'm going to need to be, let me just draw that for you. So I'm thinking a bit like this. Now my function, the roots are minus 1.5 and a half. So this is what it looks like. Okay, and I need the values when that function is positive, which are going to be those values of x and those values of x. So my solution to the red inequality is going to be that x must either be less than minus a half, or x must be greater than a half. Okay, that is the inequality solved, and that's question 9 done. Right, question 10. I've got functions f and g defined for me there, and I'm told that the function h of x is f of fg of x. And then I've got to express the inverse function, h to the minus 1 of x. Right, so first of all I better find h of x. Now I know that h of x is fg of x. So I'm going to work out g of x first, and then I'm going to f that. Well, I know what g of x is x plus 3. So actually, all I need to do to find h of x is to f x plus 3. Well, the f of x plus 3 is x plus 3 squared minus 2 times x plus 3. Just substituting x plus 3 into there. Let's simplify that. So that's going to be x plus 3 times x plus 3 minus 2 lots of x plus 3. Well, that is x squared plus 6x plus 9 minus 2x minus 6. X squared plus 4x plus 3. So that's h of x. And now what I need to do is I need to find the inverse function. So h of x is x squared plus 4x plus 3, and I need to find the inverse function. So I'm going to write y equals x squared plus 4x plus 3, and now I'm going to make x the subject. Now I've got a quadratic there, so now I'm going to need to complete the square. Now x squared plus 4x, well, that's going to need x plus 2 squared to give me the x squared plus the 4x. Then I'll need to subtract the 4, copy down the plus 3. So that is x plus 2 squared minus 1. So now I'm going to add 1 to both sides and get x plus 2 squared equals y plus 1. I'm going to square root both sides, so x plus 2 is plus or minus the square root of y plus 1. Then I'm going to subtract 2 from both sides. So x is minus 2 plus or minus the square root of y plus 1. Now I know that x is greater than or equal to minus 2. So I know that my x must be more than minus 2. So it must be minus 2 plus something, mustn't it? So there's actually only one answer that is possible here, and that is going to be minus 2 plus the square root of x plus 1. And that is question 10 done.
Right, question 11. Now we've got a function, f of x, which is defined for us there, and we're told that x must be less than or equal to 3, which will probably be important to remember later. Now, we're being asked here to complete the square, aren't we, on this expression here. 5 plus 6x minus x squared. So what I'm going to do is I'm going to write that as 5 minus x squared plus 6x. And then to complete the square here, I'm going to take a minus sign out here so that I've got a positive 1x squared there. So that's going to be minus x squared and then minus 6x. And now I'm ready to complete the square on that expression there. So that's going to be 5 minus, open the square bracket. I need x squared minus 6x, so that's going to be x minus 3 squared. That gives me x squared minus 6x plus 9. So I'll need to subtract away that 9. Right, let's multiply out that square bracket now. 5 minus x minus 3 squared plus a 9, which gives me 14 minus x minus 3 squared. So now I've written, if you look back at the question, I've expressed my original expression in the form p minus x minus q squared. And there is my answer. Okay, 11b. Using your answer to part A, find the range of values for which the inverse function is positive. So first of all, I guess I'm going to need to find the inverse function. Well, this is the function f of x here. 5 plus 6x minus x squared, and I know that that equals 14 minus x minus 3 squared. So there's my expression for f of x. And the first thing I need to do is I need to find the inverse function. So I'm going to write y equals 14 minus x minus 3 squared, and now I'm going to rearrange this to make x the subject. Let's start by adding x minus 3 squared to both sides. So that's going to give me x minus 3 squared on the left. I'll minus y from both sides as well. So that gives me 14 minus y. Right, square root both sides. So x minus 3 will be either of the square roots of 14 minus y. And now add 3 to both sides. Okay, so it looks like my inverse function is going to be 3 plus or minus the square root of 14 minus x. All I've done there is substitute the x in for the y in that expression. Now, be careful, because up at the top, it tells us that x must be less than or equal to 3. Well, in that case, we can't have 3 plus anything, so it must be 3 minus the square root of 14 minus x. So that is the inverse function there. Now, what was the question? Using part A, find the range of values for which the inverse function is positive. Right, so we're going to need the inverse function 3 minus square root of 14 minus x to be positive, to be greater than 0. So that would mean then that the square root of 14 minus x must be less than 3. So I'm subtracting less than 3 away from 3, so I end up with a positive answer. So that will mean that 14 minus x will need to be less than 9. Okay, so if I want 14 take away x to be less than 9, I must be taking away at least 5. So x will have to be greater than 5. So find the range of values for which this expression here is positive. Well, certainly x has to be greater than 5, so that you're not subtracting more than 3 away from 3. But there is another thing to spot here, and that is as follows. It's not feasible for that to be negative. Sorry, I'll rephrase that and actually get it right this time. It's not feasible for 14 minus x to be negative, because you can't actually square root a negative number. So you also need to bear that in mind when we're looking at restrictions on x, because yes, not only does this inequality have to hold so that the inverse function is positive, but also 14 minus x must be positive so that you're not attempting to square root a negative number. There's another restriction there, difficult to spot. And that means that x must be less than 14. So in fact, the range of values of x which you need here are that x must be greater than 5. Well, actually, strictly speaking, it could be equal to 0 there and less than or equal to 14. So the range of values you're looking for is that x must lie between 5 and 14. Easy to miss that second criterion. And that is that question finished. Question 12. Right, I'm given a function here, and I'm told that x must be less than or equal to 4. And I'm asked to find the inverse function. So here's my function. And again, I see it's quadratic, so I know that I'm going to need to complete the square. First of all, I'm going to write y equals my function. And now I'm going to make x the subject of this here. So I know I'm going to have to start by completing the square. I've already got a positive single x squared there, so I'm ready to go. So x minus 4 squared. That will give me x squared minus 8x, but plus 16. So I'm going to minus away the 16, and now copy down the plus 5. So this is x minus 4 squared minus 11. And now I'm ready to make x the subject of that. I'm going to add 11 to both sides to give me x minus 4 squared equals y plus 11. I'm going to square root both sides to give me x minus 4 is one of the two square roots of y plus 11. I'm going to add 4 to both sides and write that 4 at the beginning of the expression. There we go. So it looks to me as if the inverse function is 4 plus or minus the square root of x plus 11. But look out, because I'm told here that x must be less than or equal to 4. So it can't be 4 plus anything, can it? It must be 4 minus that square root. And so that is my answer there. And that's question 12 sorted. Question 13. Right, so I've got two functions here, f and g. And look at this, the function h is such that h of x is fg of x. And the domain of h, x must be less than or equal to 6. I'm going to need to remember that later, I imagine. And I'm asked to find the inverse function of h. Let's start off by working out what h of x actually is. Now I know that h of x is f of the g of x. And I know what g of x is. So h of x is f of x squared minus 12x. And I know how to f something because I'm told how to f something there. So if I need to f x squared minus 12x. So to do that, I have whatever I'm f'ing, and I add 25. So there is my expression for h of x. And now I can get on and find the inverse function. Right, so I'm going to start by writing y equals x squared minus 12x plus 25. And now I'm going to make x the subject. So the first thing I'm going to need to do, because I've got a quadratic equation, a quadratic expression on the right, is complete the square there on x squared minus 12x. I've already got a positive single x squared, so it's going to be straightforward. So it's x minus 6 squared. That gives me x squared minus 12x plus 36. So I need to subtract away the 36, copy down the plus 25. So that gives me y equals x minus 6 squared minus 11. And now I've simply got to make x the subject. So let's add 11 to both sides and swap the sides around. There we go. Sorry, add 11 to both sides. Right, now let's square root both sides. X minus 6 will be either of the square roots of y plus 11. Let's add 6 to both sides, writing that at the beginning of the expression here. So it looks like the inverse function is going to be 6 plus or minus the square root of x plus 11. But I'm told that the domain of h requires that x be less than or equal to 6. So I can't do 6 plus anything. So the correct expression is going to be 6 subtract the square root of x plus 11. And that is question 13 done. Question 14. Right, I've got two functions here, f and g. Okay. Oh, look at this, where x is greater than 1. I'll need to remember that, I'm sure. Greater than or equal to 1. I'm asked to find the fg of 2. So that's going to be the f of g of 2. So I better find out g of 2 first. But if I g2, then I have to do 7 times 2 minus 6. 14 minus 6 is 8. So now I'm going to f8. So that's going to be 5 times 8 squared minus 10 times 8 plus 7. Right, bit of calculator action here. 5 times 64 minus 80 plus 7 gives me 247. Okay, express the inverse function in that form. So I've got to find the inverse function of f, haven't I? Right, well, f of x is 5x squared minus 10x plus 7. So I'm going to write y equals 5x squared minus 10x plus 7. I need to make x the subject here. So I'm going to complete the square on the right-hand side. But before I do that, I don't want this 5x squared. So I'm going to pull out the 5 to give me 5 times x squared minus 2x. Copy down the plus 7. And now I'm ready to complete this square because I've got a single positive x squared there. So y will be 5, open bracket. Right. X squared minus 2x, so that's going to be x minus 1 squared, and that gives me x squared minus 2x plus 1, so I'll need to subtract away that 1, and then add the 7. Right, multiply out that square bracket. 5 lots of x minus 1 squared minus 5 plus 7. Tidy that up. Y is 5 lots of x minus 1 squared plus 2. And now I'm ready to make x the subject. So let's subtract 2 from both sides. So I'm going to have 5x minus 1 squared equals y minus 2. Let's divide both sides by 5. X minus 1 squared is y minus 2 over 5. Let's square root both sides. X minus 1 is the 2 square roots, either of the 2 square roots of y minus 2 over 5. Let's add 1 to both sides, writing that 1 at the beginning of the expression. Okay, so there you have it. So I think that the inverse function is going to be like this. Now I'm copying this down, copying down the right-hand side of that, but instead of the y, I'm going to use an x. Okay, now be careful. Let's go back to the question at the beginning here, because there's a restriction on the domain there of f of x, and the restriction is that x must be greater than or equal to 1. So it can't be 1 subtract anything. So in fact, only one of these solutions is valid, 1 plus the square root of x minus 2 over 5. So that is my solution, 1 plus the square root of x minus 2 over 5. And that is question 14. Where's it gone? Question 14 complete. Question 15. I'm given the function f of x here, and I'm asked to f5. So if I'm going to f5, I'm going to do 3 times 5 minus 2. 15 minus 2 is 13. Right, part B. I'm given the function g of x. Ooh, look, there's a restriction there on the domain of g. And I'm asked to find the inverse function. So I'm going to start by copying down the function here. Okay, now find the inverse function. So I'm going to write y equals this. And now I'm going to make x the subject. To make x the subject, I'm going to need to complete this square because I've got a quadratic expression on the right. Now, when I complete the square, I really only want a positive single x squared. So I'm going to take 2 out of that expression there. 2 lots of x squared minus 10x. Close the bracket, copy down the plus 9. Now I've got a single positive x squared there. 2, open the square bracket. I'm completing the square on x squared minus 10x. So it's going to be x minus 5 squared, and that will give me x squared minus 10x plus 25, so I better minus the 25 away. Okay, and copy down the plus 9. So that gives me, multiply out this square bracket, 2 lots of x minus 5 squared minus 50 plus 9. Okay, so that is 2 lots of x minus 5 squared minus 41. Brilliant. Right, now I think I can make x the subject here. I'm going to add 41 to both sides and swap things around as well. So I've got 2 lots of x minus 5 squared equals y plus 41. Divide both sides by 2. X minus 5 squared equals y plus 41 over 2. Square root both sides. X minus 5 is either of the square roots of y plus 41. Add 5 to both sides, but write that at the beginning of the right-hand expression because that makes it easier. Okay, now I'm thinking that my inverse function is going to be 5 plus or minus the square root of x plus 41 over 2. But what was that restriction on the domain? X has to be greater than or equal to 5. So x can't be 5, subtract anything. So the only answer which is valid is 5 plus the square root of x plus 41 over 2. And that is that question complete. Question 16. I'm given the function f of x, and I'm asked to find the inverse function. Right, so let's start by writing down that function f of x. It's 3x squared minus 12x plus 7. Oh, look out, there's a restriction on the domain of f. Right, so I need to find the inverse function, so I'm going to start by writing y equals 3x squared minus 12x plus 7. And now I'm going to make x the subject here. But before I do that, or because it's quadratic on the right, I'm going to need to complete this square. So I'm looking to complete the square on the right, but I see I've got 3x squared. So I don't want to complete the square without having a single x squared. So I'm going to take out the 3. I'm taking out the 3 from this expression here. So 3 lots of x squared minus 4x. Close the bracket, copy down the plus 7. Now I'm ready to complete the square. And I'm going to complete the square on this yellow expression here. So I'm going to have x minus 2 squared, because that gives me x squared minus 4x. It also gives me a plus 4, so I'm going to need to subtract that away. Plus 7, there we go. Now I can multiply out the square bracket. 3 lots of x minus 2 squared minus 12 plus 7. So y is 3 lots of x minus 2 squared minus 5. Now I can make x the subject of this expression. Swap the sides around and add 5 to both sides. Divide both sides by 3. Square root both sides. Remembering there are 2 answers there. And add 2 to both sides. writing my 2 at the beginning of the expression on the right-hand side. Okay, so it looks like the inverse function is going to be 2 plus or minus the square root of x minus 5 over 3. But what was that restriction? X has to be less than or equal to 2, so x must be 2 subtract something, mustn't it? So the only valid solution is 2 minus the square root of x plus 5 over 3. And that is my solution to question 16. Question 17. Right, I've got a function g, and it's defined there, and there is also a restriction on the domain, which I'll need to remember, and I need to find the inverse function. Okay, so I've got g of x is 5 plus 6x minus x squared. So I'm going to write y equals 5 plus 6x minus x squared to find the inverse function. And I want to make x the subject of this. Now, to make x the subject, I'm going to need to complete the square on the right-hand side since it's quadratic. Before I get around to completing the square, I'm going to write that as minus x squared plus 6x plus 5, because that's how I like it to be. Now, I don't want to start completing the square with a negative x squared. So I'm going to take the minus sign out, and in a sense, I'm going to factorize that yellow expression, taking a factor of minus 1 out of it. So it's going to be minus, open bracket, x squared minus 6x, close the bracket, add the 5. Now I'm ready to complete the square on this expression here. So I'm going to have minus, open the square bracket, x minus 3 squared. That gives me x squared minus 6x plus 9, so I'll minus the 9. Okay, y equals, multiply out that square bracket, minus x minus 3 squared plus 9 plus 5. So y equals minus x minus 3 squared plus 14. And now I think I'm ready to make x the subject. So what I'm going to do is I'm going to subtract 14 from both sides. That's going to give me minus x minus 3 squared equals y minus 14. Let's multiply both sides by minus 1. That'll make it easier. So that's, I'm going to make my way up here now. It's going to give me, if I multiply the left by minus 1, I get x minus 3 squared, and the right, I get 14 minus y. Right, square root both sides. X minus 3 is either of the two square roots of 14 minus y. Add 3 to both sides, so x is 3 plus or minus the square root of 14 minus y. Now, I'm thinking, therefore, that my inverse function is going to be 3 plus or minus the square root of 14 minus x. Great. But look out, there's that restriction on the domain, isn't there? You know that x has to be greater than or equal to 3. So in fact, it must be 3 plus something. It certainly can't be 3 minus something. So that is the inverse function. Okay, and I'm asked to write it in a certain form, aren't I? So I'll write that down here. X is going to be transformed to 3 plus the square root of 14 minus x. Okay, state the domain of this inverse function. Right, now, here is the inverse function. And let's just have a think about what different values we could put into this function. The function will work with all values of x except when this is negative, because you can't negative a square root. So in order for the inverse function to work, I need 14 minus x to be greater than or equal to 0, in which case x must be less than or equal to 14. So that is my restriction on the domain of the inverse function. And that is question 17. Where is it? That is question 17 finished. Well done for making your way through those questions. Pretty tough, especially towards the end. But did you notice how formulaic the questions become? You know exactly what you need to practice. So practice these questions until you can't get them wrong. Right, well done. Questions in the comments, comments in the comments. Hit like. See you in the next film.